Hello everyone, my name is Dr. Ramson Lodhi. I am working as an assistant professor in applied science department at SIT Pune. Today I am going to discuss interpolation. So first we discuss here what is an interpolation. The process of finding the curve passing through the points x0, y0, x1, y1, x2, y2 up to dash x and yn is called interpolation, and the obtained curve is called interpolation curve. Suppose that n plus 1 data points are given and we have to fit the curve y equals to fx, and then we have to calculate the corresponding value of y for each value of x. Then we have to substitute x equals to x0, so we get y0, x equals to x1, so we get y1, x equals to x2, so we get y2 up to dash. When we put x equals to x1, so we get yn. And here we consider x0, y0, x1, y1, x2, y2, x3, y3. These are the data points. And we have to fit the curve in this data point. So this is our fitted curve. After fitting this curve, we have to check if this curve is unique or not. So here we consider the existence of uniqueness theorem. There is a unique polynomial Pnx of degree less than or equals to n such that Pn xi equals to f of xi for I is running from 0 to n. Proof of this theorem: a set of n plus 1 tabulated points are given as x0 f of x0, x1 f of x1, x2 f of x2, xn f of xn. Here we prove this theorem by contradiction. Means we assume there is a two polynomial f of x and g of x of degree less than or equals to n. So first we have to fit the polynomial f of x of the given data point. So we get f of xi equals to small f of xi, and we have to also fit the second polynomial g of x in the same data point. So we get g of xi equals to f of xi. Both polynomials have degree less than or equals to n, and both polynomials are fitted the same data points. Then subtract the both polynomials, so we get f of x minus g of x is identically 0. Then f of x equals to g of x means both polynomials are equal. It means the interpolation polynomial is unique. Here we discuss the example of polynomial interpolation. Suppose that two data points are given, so we get the polynomial of degree less than or equals to n, and this is a graphical representation of the polynomial of degree less than or equals to 1. And when three data points are given, then we get the polynomial of degree less than or equals to 2. This is a graphical representation of polynomial less than or equals to 3. Here we describe the linear interpolation. Suppose that two data points are given, x0 f of x0, x1 f of x1, and we have to fit the line f of x equals to a0 plus a1 f of x0. So when we fit this line in the given data point, so this line is satisfy this point. So we put here x equals to x0. So we get the value of a0. And when we put x equals to x1, so we get the value of a1. And substituting the value of a0, a1 in this polynomial, so we get the f of x1 equals to f of x0, f of x1 minus f of x0 divided by x1 minus x0 into x minus xn. This is our required linear interpolation. And we have also considered here numerical example. So point are given 1, 2 and 2, 4. So x0 is become 1 and f of x0 is become 2. x1 is become 2 and f of x1 is become 4. And we have substituted this value in the linear interpolation, so we get this equation. So this, and simplify this equation, so we get 2 of x. Means f1 x equals to 2 of x. This is our linear interpolation. And here we discuss the quadratic interpolation. Suppose that three data points are given, x0 f of x0, x1 f of x1, x2 f of x2, and we have to fit the polynomial of degree 2. So we consider f of x2 is a polynomial. Then we have to fit this polynomial in this data point. So this polynomial satisfies this point. So we have to put the value of x equals to x0, so we get value of b0. When we put x equals to x1, so we get value of b1. When we put value of x equals to x2, so we get value of b2. And substituting the values of b0, b1, b2 in this polynomial, so we get our required quadratic interpolation polynomial. And we have also considered the numerical example, and data points are given x0 f of x0, x1 f of x1, x2 f of x2, and we have substituted this value in the quadratic interpolation, so we get this equation. And after simplify this equation, we get this equation. So this is our required quadratic interpolation. Thank you for watching.